Hey people, welcome back. And in this session, we are going to learn about the data transformation. So in statistics, data transformation is a process where we apply the mathematical function to each of the data point to make data more suitable for the analysis and the decision making. Because many a time, especially in the service industry or when you have the one-sided specification of the data, then my data will come mostly as a not normally distributed. And many of the analysis in statistics we perform, they are not suitable to do on the not normal distribution. So then what do? We transform that data into the normal distribution and then we do the data analysis. So two common technique for the data transformation are the Box-Cox transformation and the Johnson transformation. So some of the key point of both the transformations are here. One, the Box-Cox transformation is a family of transformation indexed by a parameter. The transformation is used to reduce skew in the raw variables and make the resulting variable look more normally distributed. The value of the parameter is chosen by the maximum likelihood of the estimation, and the Box-Cox transformation can only be used with the positive data values, which means if any of the data value is negative or less than 0, we won't be able to run the Box-Cox transformation. While the Johnson transformation is used to transform the data to follow a normal distribution using Johnson distribution system, and the transformation select a function from 3 different Johnson families to transform the original data into the data that follows a normal distribution. The Johnson transformation can handle value less than 0 as well, which is negative value, which Box-Cox is not capable to handle the negative values. And the transformed values can be stored in the worksheet for the further analysis. I will show you how to do this. So overall, Box-Cox and Johnson transformation are the useful technique for data transformation in statistics. Box-Cox transformation is family of the transformation used to reduce skew in the raw material, while Johnson transformation is used to transform the data follow a normal distribution. How do we do this? Let us understand in the mini tab. So suppose I have generated this data in the last session. I was explaining about the individual distribution identification we have done, and this is my not normal data. So first thing always we do, check the normality of the data. Let's say with the help of normality test or Anderson-Darling test. I select this data and I check the p-value of this data. It's less than 0.05, which means data is not normal. The next step will find out which distribution my data is following, that is individual distribution identification. And when I look for individual distribution identification option here in stat, quality tool, and individual distribution identification, I select this data, subgroup size 1, overall I select like this, and here is the output. In the output, forget about all this graph. Directly you can jump to the goodness of fit test table, and in this you will find these p-values. So whichever the p-value is the highest, the distribution your data is following, which means my data currently is exponential, and it is suggesting if you transform by Box-Cox, it will give you the p-value of 0.672, and if you transform with the Johnson, it will give you the p-value of the 0.492. So ideal condition whenever you do the process capability analysis, we should be doing with the help of Johnson transformation. And when you do the control chart plotting, then we'll be using the Box-Cox transformation. So let's first use the Johnson transformation for this data. And how do we see? I'm just naming this sheet as in Johnson, and here is the Box-Cox. We'll be doing this. So this is my data. Let's see how the Johnson will work here. We'll go to the stat, then quality tools, and in quality tools, I select the Johnson transformation. Click on this. Select your data which is already not normal. And you want to store this not normal data into the column C2, which is the Johnson transformation. That's all you have to do, nothing else, and click on OK. So now the data which I got here in my Excel in this mini tab, this is a Johnson transform data as a normal data. Now let's check the statistics, and if I do this, I can find out the previous p-value was less than 0.05, and after transformation this p-value is 0.492. So this data has been transformed to the normal. We can do the analysis whatever we want, which will best fit for the normal data. Now, how to do Box-Cox transformation? The similar way, we'll go to Stat, Control Charts, and in Control Chart, first option is the Box-Cox transformation. Click here, select your data as a not normal, subgroup size select as an 1. Where do you want to store? Go to the option, and you can say store transform data in this Box-Cox column, which I already named. That's all. Click on OK. Click on OK. And this data is now transformed as a normal data, which you can see Box-Cox transform. Background statistics, you can check here. Now, in case you wanted to find out that how this data has been transformed, is what are the p-values are coming. So you can run a normality test, because my data converted from the same not normal data, and it is a Johnson and Box-Cox both. I want to see parallel both. So then we'll go to the graph, probability plot. In probability plot, select single because your data is in the single column. Select both Johnson and Box-Cox. In multiple graph, you can see in separate panel, better for the better look, and click on OK. And now you will check the p-values of both the data. So the first p-value for the Johnson is 0.492, data is transformed to the normal. And second p-value is for the Box-Cox 0.672, and data is transformed to a normal data. This is the way we transform the data, but as an Six Sigma professional or as an statistical professional, it is never recommended to transform the data. Otherwise, you will lose the originality of the data. And when you are changing something and you are expecting the same result from that, it won't give you the correct result. So the transformation of data is never recommended. But yes, in case it's a do or die situation, you can transform the data. Thank you so much, people. I'll see you in the next session.